Welcome back, engineers. We are looking at a lever problem that kind of incorporates everything, and this one is about a bottle opener. So let's take a look. To celebrate their exam results, an engineering student opens a bottle of root beer. The bottle opener has an efficiency rating of 72%. While pushing upwards with a force of 3.5 pounds, the bottle cap releases. The bottle cap requires 15 pounds of force to be pried off the bottle. We want to find the ideal mechanical advantage and the approximate width of the bottle cap, also known as the effort arm. Okay, so just to discuss this for a moment, this is a lever, right? I mean, it's not like a seesaw lever like we've seen in the past, but if you think about what we're looking at here, the fulcrum is over here on the far side of the bottle cap. That's where, when you open up a bottle, it rotates, right? The bottle cap is going to rotate around that point. So our fulcrum is right there, if you wanted to imagine it like we've seen in the past. And then the resistance force is coming from the other side of the bottle here, the bottle cap, and the effort force comes from you pushing upwards on the handle of the bottle opener. So what class lever is this? Well, this is our fulcrum is all the way on the one side, our effort force is on the left side, and our resistance force is in the middle. So again, you just look and you go, hey, the resistance force is in the middle. That must be a second class lever, similar to a wheelbarrow. Okay, so let's, before starting a big problem like this, I always recommend having your equations out and then really figuring out what information is given to you. So let's start there as we read through the problem again. We were told, let's highlight some of the important pieces here. Efficiency rating of 72%. Okay? Pushing upward with a force of 3.5 pounds. That is our effort force. And then the bottle cap requires 15 pounds of force to be pried off the bottle. That's going to be our resistance force. So let's jot those all down. We know our percent efficiency is 72%. We know that our effort force, FE, is 3.5 pounds. We know that our resistance force is 15 pounds. That's the force needed to get the bottle cap off. And then let's take a look at our diagram. We have 6 inches is given to us here. Well, what's that? That's the distance between our effort force and our fulcrum. So that is our effort distance, DE, 6 inches. And the question mark here, that is going to be our, this was our effort distance, and the question mark is our resistance distance, DR. So DR is unknown. Okay, let's start to take a look at some of the things we could figure out. Remember, to use any of our equations, you need to have only one missing variable. We still don't have IMA. We still don't have AMA. So let's take a look and see which equations can we use. Can we use this first equation? Well, we don't have IMA and we don't have the resistance distance. So we can't use this equation yet. Can we use the second equation? AMA, we don't know. We do know FR and FE, so we could start off with this equation. I think that's what we'll do. So I'm going to switch to a new color here. Let's calculate the AMA. That's going to be FR over FE. FR is 15 pounds. FE is 3.5 pounds. Remember, pounds cancels out in this calculation. 15 divided by 3.5, I need my calculator. 15, turn it on, clear it. 15 divided by 3.5. 4.29, I'll round that to. 4.29. Okay, pretty good mechanical advantage there, 4.29. We can go ahead and, actually that's not asked for us in the answers, but we will need it. Let's take a look now at our third equation. Do we have percent efficiency? Yes, we do, 72%. Do we have AMA? Yes, we do now, since we just calculated it. Do we have IMA? We do not. So we can use this equation to figure out the IMA. Let's go ahead and do that now. So, I'm going to fill in stuff as we go. Percent efficiency is 72. So 72 equals 100 times AMA is 4.29 divided by the IMA. Let's start to solve out. I'm going to divide by 100 on each side, divide by 100 on this side, divide by 100 on that side. 72 over 100 will give me 0.72 equals 4.29 over IMA. Next up, we'll do a little cross multiplication here and cross division. I'm going to get IMA equals 4.29 divided by 0.72. I'm going to need my calculator again for that. 4.29 divided by 0.72. 5.96. So we have our IMA now. Again, it has no units. Remember that your IMA is under ideal conditions where there would be no friction. So your IMA should always be, so a little side note here, IMA is always greater than or equal to your AMA. So we have IMA, we can put that in there. It would be 5.96. Unit would be none. And then we just need the approximate width of the bottle cap. So the last thing to do here would be to, let me make myself some room here. I'm going to get rid of this picture. Okay. The last thing to do here would be to go back, we used this we used our second equation, we used our third equation, but we did not use the first equation. So I'm going to go back and use the first equation. IMA equals DE over DR. The IMA is 5.96. The DE is 6 inches. The DR is unknown. Now you might be thinking, hey, all of our other problems were done in feet. Shouldn't we convert to feet? And you could convert this to feet. If I leave it in inches, though, it just means that my answer will come out in inches. And I'm okay with that. So all we have to do now is cross multiply. DR will equal 6 divided by 5.96. Pull up my calculator, 6 over 5.96. And we get a little bit more than 1.007. And again, that's going to be in inches because that number 6 was in inches. So we've got our answer there, 1.007. We put that in here. And our unit would be inches. Now if inches was not a unit choice, we could convert that to feet, but that's not going to be necessary for this problem. All right, hopefully this helps. Good luck with the problem set.